All right, in this video, I'm going to go over using the distance formula in a word problem. So I have a word problem here. On Saturday, it took Jen 3.6 hours to drive to her mother's house for the weekend. On Sunday night, the return trip took 4 hours due to heavy traffic. It was a little longer than 3.6 hours, right? Her speed was 5 miles an hour slower on Sunday than on Saturday. What was her speed on Sunday? Well, I'm guessing we're going to need to know the speed on Saturday to figure out what the speed was on Sunday. So let's just write down what they want us to solve for. So they want speed. Now, what is the distance formula? First of all, it's, stop me if you've heard this before, it's distance equals rate times time. D for distance, R for rate, T for time. Rate can also mean speed, right? That's a key word, speed. So what we're solving for is the speed or the rate on Sunday. So R sub sun is what we're searching for. So a little question mark there. So that's what we want. That's what we want to know. But what do we already know? Well, first sentence, it took Jen 3.6 hours to drive to her mother's house. So that was the first trip, and that was Saturday. So we can say T for time, sub SAT, T sub Saturday. Time it took Saturday was 3.6 hours. Okay, we know that. On Sunday night, the return trip took 4 hours. Okay, so T Sunday is what? 4 hours. Okay. Okay, what else do we know? Her speed was 5 miles an hour slower on Sunday than on Saturday. So slower on Sunday. So, So the rate of speed on Saturday would be whatever the speed was on Sunday plus 5, because it was slower on Sunday and faster on Saturday. Plus 5 miles per hour. Well, that's a bad handwriting. All right. Anyway, see what I did there? Another way you can write it is the speed on Sunday is equal to the speed on Saturday minus 5 miles an hour. Just as useful. In fact, these are the same equation, really, just rearranged a little bit. All right. So what are we solving for? Speed on Sunday. We want this. We want that. So in order to get that, we need the speed on Saturday. But when we use this distance formula, we can only use one. We're going distance. Well, I mean, what is the distance on Saturday? I don't know. We don't know how far she went. Well, don't get discouraged. They're not going to tell you everything. We know what? She drove to her mother's house, and then she had a return trip. So the distance on Saturday is equal to the distance on Sunday. That is key. We don't know the distance. We don't even care. All we know is that it's equal. Why does that matter? So when we come up with the distance on Saturday equation equals the rate on Saturday times the time on Saturday, we can say that that is equal to the distance on Sunday, which is equal to the rate on Sunday times the time on Sunday. Okay, whoa, wait a minute. All these things are equal? Yes. So we can just take out the distance on Sunday and the distance on Saturday and maybe one of these equal signs and just say rate of Saturday times the time on Saturday is equal to the rate on Sunday times the time on Sunday. Well, how does that help us, Joe? Well, I'll show you. Rate Saturday times Saturday equals rate Sunday times Sunday. Let me just consolidate that down and do a nice thing there. Okay, well, what can we do here? Well, we can start substituting in all the things that we know. T Saturday is 3.6. Got it. R Saturday is R Sunday plus 5 miles an hour. We can substitute that whole thing in there, right? And what we're looking for is R Sunday, so we don't really care what R Saturday is. So we can just substitute this in for R Saturday. You see that? What? And parentheses matter, okay? Especially when substituting, because that's the difference between using the distributive property on this 3.6 and just saying R Sunday plus whatever 5 times 3.6 is. It's got to be 3.6 times the rate on Sunday plus 5 times 3.6. Distributive property matters. Parentheses matter. Now, the rate on Sunday, we don't know what that is. That's what we're solving for. So we don't need to substitute. Time on Sunday is 4 hours. That was easy. Okay. Well, now all it is just algebra, right? We just got to figure out, we just got to isolate the variable that we're searching for. And we don't even have to have that R sun in there anymore. We could just say it's R. That's what we're searching for, just to make it faster on us. So we're going to distribute this, right? Distribute the 3.6, so it's 3.6R. Let me just write a line down here so you can not confuse it with the stuff I wrote over there. 3.6R plus 5 times 3.6. Okay. Whoa. Well, let's assume that you don't have a calculator. Equals 4R. Let's just combine those down. Let's just assume you don't have a calculator. You're not allowed one on a test or something. Maybe a strict teacher or something like that. I don't know. 6 times 5 is 30, right? 3 times 5 is 15. Plus 3 is 180. Move that decimal over. So that's 18. Check my math on that. You can. Sounds right to me. All right. So 3.6R plus 18 equals 4R. All right. Well, let's get this R over here so we have the R's on one side. Or if you prefer to have your variable on the left, which most people do, I'm going to do that. We're going to move the 18 over there while we're at it. Subtract 18 from both sides and subtract 4R from both sides. Okay, So this gives us a negative 0.4 r equals negative 18. Okay. Well, let's assume you don't have a calculator again. Dividing by a negative cancels out the negative that's already over there. So dividing by a negative 0.4 gives us a positive. It's going to be r equals something. So let's do this math off to the side again, assuming you don't have a calculator. 18 divided by 0.4. What's 0.4? As a fraction, right? You can write that as a fraction. So it's actually 4 over 10, right? And when you're dividing fractions, you take the reciprocal and multiply by the reciprocal, and you'll get the same answer. Okay. You can reduce this fraction down to divided by 2, 5 over 2, right? So 18 divided by 2 is 9. 9 times 5 is 45. Miles per hour is how fast Jen was going on Sunday. Thanks for watching.